So here the question is saying that a coil is placed in magnetic field such that the plane of coil is perpendicular to the magnetic field. So you have to comment about the magnetic flux. Okay, right. So we know that suppose this is the area that we are talking about, right? And let's say this is the direction of magnetic field through the area, right? So it is passing through it, right? The magnetic field lines are passing through the area. The magnetic field lines are magnitude B, right? And the plane of that area is circular, but the area, the direction is this one. The area vector, the direction is this, and the angle between the magnetic field and the area is, let's say, theta. So the flux is given by the dot product of B and A, the magnetic field and the area, right? So now the question is asking, let's see the first one. By changing the magnitude of the magnetic field within the coil, can we change the magnetic flux? Of course. This phi, if I find the magnitude of the phi, this phi is magnitude of B times the magnitude of A times cos of the angle in between, right? So obviously, if you change the magnitude of the magnetic field, the flux here, this is the flux, right? The phi is going to change. So this is correct, yes. By changing the area of the coil within the magnetic field, if you change this area A, obviously this is going to change, yes. By changing the angle between the direction of magnetic field and the plane of coil, if you change this theta also, then also the flux will change, of course, yes, right? Now let's see the fourth option. By reversing the magnetic field direction abruptly without changing its magnitude, right? So if you change the direction abruptly, so the flux will be the same in magnitude, right? The flux will be the same in magnitude, but the flux will be negative in that case, right? For example, if you take a coil like this, let's say this is the magnetic field direction, and let's say the area is also this only, right? The area right now, the angle between A and B is 0, right? So here the flux is going to be mod of B times mod of A times cos 0, that is 1. If you abruptly change and make the magnetic field downward, B, this flux is going to be negative B times A, okay? But still it is going to be the same in magnitude, okay? Because cos of pi, the angle, when you change the direction of B, the angle between A and B becomes pi, 180 degree. Cos of 180 is minus 1. So flux will be negative of what it was before changing the direction of magnetic field, but magnitude wise it is going to be the same. And we don't have any option like A, B, C, D. Otherwise, had there been an option A, B, C, D, we'll be choosing that. There is no option like A, B, C, D. So the best option that we can give here, A, B, C, okay? Because D, yes, the flux is changing, it is becoming negative, but magnitude wise it is going to be the same, and flux is a scalar quantity, right? The most appropriate answer that we can give here is option number 2. So this will be our answer here, option number 2 for the question. Okay, thank you.